Hi guys, welcome back to my channel. So today we're gonna be continuing our last lesson on the number patterns and series. So yeah, at the end of the last lesson, I did mention that we're gonna be looking at determining the sum of n terms of the sequences that we've discussed, and then also I think it's important to spend some time deriving those formulas, because in the exam they can ask you to derive one of the formulas for some of n terms, either for arithmetic sequence or geometric sequence. So you need to know how to derive those so that you are not caught by surprise in the exam. Okay, so yeah, let's get to it. So we're going to start with arithmetic sequence. So for arithmetic sequence, I'm going to write AS for noting arithmetic sequence. So yeah, the formula that the examiner they expect you to know and be able to apply and derive, it is noted as Sn equals to n over 2a plus n minus 1 d. So yeah, essentially this is the general summation formula, right, for arithmetic sequence. So in terms of what the formula means, it just means that if you know, if you know, like, yeah, of course the question will ask you, like, okay, determine the sum of let's say first n terms in a sequence. So essentially it gives you the sum of the first n terms in the sequence that you have, right? So yeah, I will quickly just show you example of how this formula will apply. But essentially this Sn means sum of n terms. So determining the sum of first n terms in a sequence. Yeah, it's important to just note the fact that it's the sum of first n terms, like the first n, not just any terms, right? Okay, and then a. So this is, remember, the first term in your sequence. The first term in your sequence, we've covered that in the previous lesson. It's the same a that you find on t equals to a plus n minus 1d, like in that general term formula, right? So it's the same a. And then d, this is the constant difference, right? The common difference on your sequence, right? We also covered this in the previous video. Yeah, please refer back to that if you're struggling to to remember. But also, like, yeah, as we do example, you probably remember what each of these parameters means, right? Okay, so yeah, there's another formula that sometimes you see. So the formula is n over 2a plus l, right? So sorry. So this formula is alternative of this one. So like the both will give you the same results. So essentially in this formula, so a is the same as a in this case, and then L is the last term, in a sequence. So that last term is noted as what is noted as a general term formula, right? So essentially this is Tn. Yeah, essentially that L is Tn formula, right? So, but yeah, so either you can use this formula or you can use this one. So I prefer using this one because it applies under all circumstances, right? Okay, so yeah, without wasting time, let's look at the example of how we can use this formula, right? So how we can use that formula. So let's suppose examiner gave you a sequence that's like 3, 5, 7, 9, right? And then 11. Yeah. So let's suppose this was the sequence that the examiner gave you. So by just looking at the sequence, I'm sure you can guess that it's definitely arithmetic sequence because, you know, difference 5 minus 2, 2, 2, 2. So yeah, you can tell that, you know, this is definitely, you know, arithmetic sequence. So yeah, so let's suppose the question asks you to determine the sum of the first 8 terms in this sequence. Determine sum of the first 8 terms in this sequence. What's the sum of first 8 terms in this sequence? So yeah, you definitely know that you're gonna need to use our formula that we just discussed in the previous page. So the formula that we need to apply, it's, let's just write it here. So it's n over 2 a plus n minus 1 d. Yeah, that's the formula that we need to apply, right? But then, so let's just refresh our mind. So for us to apply this formula, we need to know the value for a. Remember, we said what's the a? A is the first term in the sequence, right? So a in this case is going to be 3. And then what's d? D is the common difference, right? So d is going to be 2. So if we substitute those values in our formula, then we're going to have our Sn equals to n over 2. 2, what is a? A is 3 plus n minus 1. And then what's d? D is 2, right? So if we simplify, you're going to have n over 2, 6, 2 times 3 is 6, plus n minus 1, 2. So I can simplify further. I'm just making it, you know, into many steps. But yeah, just so that you follow. So essentially here, so if you multiply 2 times n, you get 2n times 2 times minus 1, you get minus 2. Minus 2 plus 6, that gives you 4. And then so you have 2n plus 4, right? So this simplifies. If you multiply throughout by 1 over 2, then you get n, and then you get n plus 2, right? So that's like, you know, your Sn formula. So now since you've derived the Sn formula, so then the question asks us to determine what? The question asks us to determine S8, right? So how are we going to get S8? So to determine S8, which means we need to substitute 8, which is n, in the formula, and then we determine the sum of the first 8 terms in this sequence. So that's going to be S8. That's going to equal to 8, remember n, 8 plus 2, right? So that's going to be 8 plus 2, which is 10. 10 times that's 80. So which means the sum of first 8 terms in our sequence here is 80. So yeah, that's is exactly how we will apply the formula, right? So firstly, just quickly to recap, you need to derive the value for a and d, and then you know a is the first value in your sequence, and then d is the common difference. And then yeah, so once you have, like, you know, once you have your a and then your d in your formula, then what you need to do then is just to simplify and then get your Sn formula in a simplified format. And then now you just substitute your n, right? You just substitute your n, your 8, then you get the answer. Just simple as that. Okay, so yeah, now I'm just going to move into helping you to see how this formula was derived, right? Because sometimes it's important. Okay, I believe that it's always important to know how things are derived, as opposed to just applying without really understanding how they were derived. And also for you, in your case, like the examiner can ask you in the exam question to derive this formula. So it's important to make sure that before the exam, you're able to derive this formula yourself, right? Okay, let's look at how we can derive this formula, right? So firstly, remember for arithmetic sequence, we mentioned that Tn, which is term number for any term in the sequence is a plus n minus 1 d, right? So that's like your Tn formula. Right? And then Sn, so we're trying to derive, so what are we trying to do? Required to prove that Sn equals to n over 2a plus n minus 1 d. So this is what we are required to prove. We need to prove this, right? So, but yeah, for us to prove this, we need to remember this result first. We need to remember this result because, so in our proof, we will need to expand this from the first principle. What does Sn mean? So Sn means T1 plus T2 plus T3 all the way plus Tn, right? Okay, let's call this equation 1. Let's call this equation 1. Okay, this is exactly where it's important to remember. This is where the trick is. So what we need to do, we need to rewrite this summation, but then now we need to write it in a what? In a reverse order. In a reverse order. So if you write it in a reverse order, so we're gonna have Sn equals to Tn plus Tn minus 1 all the way plus 2T2 plus T1, right? So let's write this as equation 2. So I think this is very important. I'm just gonna pause here and then repeat the point. So it's important to make sure that firstly you write Sn in this expansion form, and then the second step, you're gonna have to reverse these terms on the right hand side, right? You're gonna reverse them, and then you still get the same result, right? So, okay. So then the third step that we need to do now, we need to substitute, for this T1, T2, and up to Tn, we need to substitute into what? Into this formula here. We need to substitute here, right? So if we substitute there, so we're gonna get, so this guy is gonna be Sn equals to, if we substitute 1 into n, so you're gonna get a, obviously, because it's gonna be 1 minus 1, then cancel. And then the second term is gonna be substitute 2, like into the formula, remember T2. So that's gonna be a plus d, and then all the way, right? Then the last term that you substitute is Tn. So if you substitute n in the formula, so you're gonna get like that term. It's just gonna be Tn, which is a plus n minus 1 d, right? So that's the last term. So, and then we need to do the same for, we need to do the same for our second equation, right? So we're gonna have Sn equals to, what's Tn? Tn is this, remember? So you're gonna have a plus n minus 1 d. And then, so we're going backwards. So Tn minus 1, that's like a plus n minus 2 d plus all the way up until what? Up until a plus d plus a. So a is the last term, right? A is the last term there. So now you have two equations that you have expanded, which is this one and this one, right? So now we need to sum the two equations, right? Now we need to sum equation 1 and 2, right? You'll notice interesting pattern. When you sum equation 1 and 2, you're gonna notice a very interesting pattern. You're gonna notice that, you know, this guy, so this guy is gonna be mapped with, it's gonna be summed with this, and this is gonna be summed with this, and then you continue in that order, right? So what you're gonna notice is that, you know, so remember you are saying second step is equation 1 plus 2, so which implies that Sn plus Sn equals 2. So this is where you need to be very careful. So when you sum this, so you're gonna have 2a n minus d. So you take this and sum, you're gonna have same thing, 2a plus n minus 1d, right? So yeah, that, like, that term is gonna repeat n times. It's gonna repeat, remember, because since you have n terms, so every time you sum the two numbers, then they're gonna give you this answer. They're gonna give you this guy. They're gonna give you a plus, okay, so 2a plus n minus 1d. Then you continue, so you're gonna get this again. So you add the second time, you're gonna get the same thing, 2a plus n minus 1d. So if you continue into that, so you're gonna continue to get these values up until the last term, right? So now what we need to do, we need to recognize that these terms are repeating, and how many of them are repeating is n times. So that means then on the left hand side, Sn plus Sn, that gives us 2 Sn equals to n, which is number of times these terms are repeating, times 2a plus n minus 1d, right? So then now this gives you Sn equals to, we need to divide by 2, so n over 2, and then so that gives 2a plus n minus 1d. Look at that. Okay, so then that means then we have proven our formula. So just quick recap on what needs to happen. So first step is to remember this formula, right? Remember that formula. And then once you remember that formula, so now you need to write your Sn in terms of, like, intuitive understanding of it. So which is expansion of T1 plus T2, expand it all the way to the Tn. And then second step is to write it again in the reverse order. So starting from Tn going down to T1. And then now you just substitute into the Tn formula to get those equations 1 and 2 expanded in this form, right? So once you expanded them in this form, then now you're gonna add equation 1 and 2. When you add equation 1 and 2, you're gonna realize that on the right hand side, you get the repetition. You get the repetition of those terms, and this term repeat n times. So then you have to multiply by n times, because otherwise it's gonna take the whole day to add one by one, right? Okay, so then now once you added those terms, then you just simplify, and then you eventually arrive at this final answer that you're looking for. Okay, so I believe now you're able to derive the formula and you understand the application of it. Obviously, there are going to be a lot of question papers that I'm going to be attempting with you, and then you're going to see how we apply this formula, and how we derive it. If if there's a question that requires to derive it, I'll just do it maybe one more time so that it stays in your brains. Okay, so now let's move to a geometric sequence. So geometric sequence. So yeah, geometric sequence. So geometric sequence. Geometric sequence. Yeah, so sorry for bad handwriting. So for geometric sequence, so yeah, so the formula that you expected to know and be able to apply and derive is Sn equals to a r n minus 1 over r minus 1. Or sometimes you might see a formula written as 1 minus rn over 1 minus r, right? So look, it doesn't really matter. Let me write this neatly. Okay, so Okay, so yeah, it doesn't really matter. It doesn't really matter which one of these two formulas you use, right? What I usually see people doing or examiners doing is, so this formula on the right, so this one they usually use it if, like, let's say the common ratio is between -1, so they're just trying to avoid having to divide by a negative number, or like dividing by a decimal number. So, but yeah, look, that doesn't really change the result, whether you use the one on the right or use the one on the left. So you still get the same result, right? So the notation is just slightly different based on what? Based on how the formula is derived, right? So depending on how you derive the formula, so that will determine whether you get this form or the other. But yeah, the answers will always be the same. As long, just make sure that there's a consistency between this term. Like if you're taking R and R to the power of n minus 1, make sure that here you don't do other way around. You don't swap things. Because if you swap things, then yeah, that will give you an answer that is negative, or like that is wrong. Okay, so again, so just to draw a parallel between this SN formula and what you've learned so far. So you learned that Tn equals to A Rn minus 1, right? So A is the same A. So this is the first term in your sequence. R is the common ratio in your sequence, the one that we derive, or the one that made geometric sequence special. So yeah, those are the same. So as long as you know A and R, then you can be able to derive the formula, right? And then you can also apply it. So yeah, let's look at the example of how we can apply this formula. And then from there, we can also have a derivation of this formula, so that you know how to derive it in exam if they ask you to. Okay, so let's look at the example. So suppose examiner gave you a sequence that was 3, 6, 12, 24. Okay, yeah, so I'm just gonna leave it at that, right? So, and then now they ask you determine the sum of what? The sum of the first 8 terms in this sequence. Determine the sum of 8 terms in this sequence. What are the sum of the first 8 terms in this sequence? So you know that we will need to derive the SN formula, right? What is SN? SN equals to A Rn minus 1 over R minus 1. Please make sure that all the time, if you the order of Rn to the power of n minus 1 should be the same, should be consistent. R, they should always start, or ones, they should start first. So don't make a mistake of having R to the power of n minus 1, and then in the denominator you have 1 minus R, because you're going to get the wrong ones. Okay, so in this formula, then what's A? So we know A is what? A is the first term, right? Which is that boy there. That's A. And then what's R? We need to define, we need to determine R. R is, we know it's a ratio, right? It's the ratio of consecutive terms, right? So 6 divided by 3. So that's 2. 12 divided by 6. That's 2. So then we know that our R is 2, right? So A is 3, and then R is 2. So we can substitute in our formula, so which is going to be 3 to the power of 2n minus 1 over 2 minus 1. 2 minus 1 is just, okay, so it's just 1. So if you allow me, I'm just going to leave it at that, right? So, okay, so then if we expand in the bracket, so if you expand the bracket, so you're going to have 3 times 2 to the power of n, and then 3 times minus 1, that's going to give minus 3. So that's the formula. Or we can leave it at this, right? So it's fine. So that or this, that's still fine. Okay, so now the question, remember, ask us to determine what? The sum of the first 8 terms in this sequence. So then for us to determine the sum of the first 8 terms, we'll need to substitute S8. S8 is gonna equals to 3, 2. What's n? N is 8 minus 3, right? So yeah, so then we need to simplify this. Sorry, so I'm running out of space. So I'm just gonna move this to this here. So if we simplify that, so which means we have, actually I don't have a calculator next to me. I just try to use my head. So yeah, so we have 2 to the power of 3 times 2 to the power of 5, right? So yeah, 2 to the power of, so I'm just like, expanding that 2 to the power of 8. So yeah, so this is 8, right? This is 8, and then this is, I think this is 1, 2, 5. So let's see. So that's 2 to the power of 4. So that's 16. 16 times 2. So that's 32. Oh, sorry, that's 32, man. That's 32. That's 32. So yes, 32 times 8. Yeah, 32 times 8 times 3. So let's see, 32 times, that's 64. 64, that's 128. So 128, that's 128. Yeah, so that's 2, yeah, that's 256. Okay, so that's 256. So 250, yeah, okay, so yeah, essentially you can just try to apply in the calculator. 256 minus 3. Yeah, don't try to work it out like me in exam, because you might waste time. So you just punch in the calculator at this stage. So yes, essentially this 2 times 256, and then you minus 3, right? Then that will give you the answer that you're looking for. Okay. So yeah, now let's look at how can you derive this formula. So proving this formula essentially, that this is indeed the sum of n terms in a geometric sequence. So yeah, I mean, doing that, so that requires us to, so we are required to prove, so RTP just means required to prove. So you're required to prove that Sn equals to A R n minus 1 over R minus 1. Right, so okay, so remember we needed to know Tn R minus 1, right? So yeah, the first step, so we're gonna say, so Sn equals to T1 plus T2 plus T3 plus Tn, right? Like, let's let this to be equation 1, right? Equation 1. So equation 1. And let's just make things a little bit neater. Okay. So that's equation 1. Okay. So then second step, so be careful, don't memorize the steps between how we derive the Sn for arithmetic sequence and Sn for a geometric. So we're not gonna write this in a reverse order. So the trick here is for us to multiply, we're gonna multiply Sn by a common ratio, right? To get another equation. So what you're gonna do, you're gonna say, okay, Rsn, so in other words, you multiply Sn that you have then as a first equation by R, common ratio, then that's gonna give us Rt1 plus Rt2 plus Rt3 plus Rtn, right? Okay, so that's gonna be equation 2, right? Equation 2. So now what we need to do, so let's substitute t terms by what? By this formula. In other words, let's substitute the actual values based on the formula for the t terms, right? So on the Sn, you're gonna have Sn equals to, so if you substitute T1 or 1 into the formula, then we're gonna have A, right? Remember, because it's gonna be A out to the power of 1 minus 1, anything to the power of 0 is 1. So that times A, that's like A. And then now we substitute 2, then we're gonna get A times, R to the power of what? 2 minus 1. So that's gonna be AR. Okay, then the other term is gonna be AR2, because it's gonna be what? 3 minus 1, that's 2. Then yeah, we're gonna do this up until the last term, which is TL. So you're gonna substitute N there. So that's gonna be Rn minus 1. Okay, so remember that's still equation 1. So what you're gonna do now, remember on the second equation we did what? We multiplied Sn by R to derive the second equation. So we're gonna do that, but this time we're gonna substitute T terms by what? Into the formula, right? Just like we did here. So what you're gonna do now is gonna have R Sn as equals to, so look what's gonna happen. So if you multiply T1, remember what's T1? T1 is A, right? So essentially it's like you multiply in this sequence that you have here, you multiply it by what? By R. That's what you're doing. So which means you're gonna have, I'm just gonna move one step further, right? Just to show you a trick here. So if you multiply, so I'm gonna have AR as the first term, and then I multiply this term. So this term by R, this one by R. So I'm gonna get AR squared, and then so if I continue to the end, so I'm gonna have AR n minus 1 plus ARN, right? So essentially, most of the terms in equation 1, right? So equation 1 here are same terms as in the equation 2, which is very good, right? Which is very good for us. Why? Because if we decide to say, okay, let's take the equation 2, right? Equation 2. Okay, let me just use this. So if we then decide to say, okay, I take equation 2 and minus equation 1. Let's see the results that we get. What does this imply? Okay, so that implies that if we take this guy, we minus this, then we can be able to eliminate most of the terms in these sequences. Like we only want to be left with 2 terms, which is what? Which is this guy and this guy, because everything else looks the same. So we're just going to wipe it out, right? Okay, so let's see. So essentially we're going to have Rsn minus Sn equals to, remember we have A in the first formula, right? So that's going to be minus A actually. So let's go back. So you have A, so you are taking this guy, you minus it, so essentially it's going to be 0 minus, so you're going to have minus A. So that's going to be minus A plus A R to the power of n, right? Because this is the only last term that is left there. So you have A R to the power of n. Okay, so this is very interesting. So this is what the 2 equations simplify to if we minus them. So then now if you proceed further, so if you take out the common factor here, which is Sn, we have R minus 1. And then on the right, so on the right, what's the common factor there, which is A? So we have A R n minus 1, right? So like, yeah, if you're confused, so I just rewrote in this. Remember, this is the same as R n minus A. So I just rewrote it, right? So I just took A outside as a common factor. So Then what we can do, then now we can just divide both sides. So you can divide both sides by what? Both sides by this guy, right? So that we are left with Sn on its own. So then this implies that Sn equals to a r of n minus 1 over r of minus 1. Okay. So note what will have happened. Note what will have happened. So if instead of like saying equation 2 minus 1, you said 1 minus 2. So you will have had the results that look like this. You will have had the result that looked like this. I'm not going to do it just to save time, but the results will have been a 1 minus r of n over 1 minus r. So which talks to, remember at the start I mentioned that there are two formulas that they usually use, this one or this one. So yeah, depending on how you solve for this or how you derive for Sn, it will determine if you get this guy or this guy. So it's quite important to know which one, which one you use under what circumstances. Okay, so I mean the last few things that are outstanding. So like yeah, in exam there are sometimes questions where examiner they ask you to determine if a sequence, if a geometric sequence is convergent or not, right? So firstly, what do they mean when they say a sequence is convergent? So when they say a sequence is convergent, they just mean that that sequence it doesn't run on into infinity, right? So it runs to a certain number, so it converges. It tends towards a certain number. As you increase the number of terms in the sequence, or as you sum them, they get towards a certain value. They don't just run over to infinity, right? So, and then how are you able to determine that mathematically? How are you able to tell if the sequence that you have is convergent or not? Okay, so convergent, non-convergent, right? Non-convergent. So a sequence is said to be, the geometric sequence is said to be convergent if ratio, like the common ratio is between what? Is between -1 and 1. So if your R is between this 1 and -1, then your sequence is going to be convergent. What does that mean? What that means that S infinity, like Sn, Sn tends to S infinity, so in other words, as your n increases, as you sum more terms, like this guy tends to S infinity. So S infinity it's more like it's a convergent number, right? Convergent number. So how do you get this convergent number? Remember, so this convergent number is a over 1 minus r, right? Okay, why is it a over 1 minus r? It's because if you go back, so as n increases, right? So remember, this guy is very small, right? It's very small. It's between -1 and 1. So as n increases, like as n expand, so this guy will tend to this number will just tend to 1 essentially, right? So I mean, like this number will tend towards 0. What am I saying? Yeah, the number will tend towards 0. So that number will tend to, so let's just go back. So essentially this is derived from that. So as when n tends to infinity in your a r n minus 1 r minus 1 formula, so this guy will tend to 0. So as n tends to infinity, so that guy will tend to 0, and then essentially you're gonna have a times -1 over r minus 1. So if you multiply by -1 both sides, we divide by -1, then we're gonna have a over 1 minus r. Yeah, so essentially, this is your sum to infinity. So if the examiner asks you to determine sum to infinity, so this is the formula that you're supposed to use. And that's the number that, your sum will converge to. Then otherwise, if the ratio is not that, otherwise, if R is greater than 1 or R is less than -1, then yeah, it's non-convergent. Then you're gonna use your usual SN formula. Okay. Yeah. Okay. Thanks, guys. I know this is pretty long video, but yeah, I think the details of what you've covered is quite important. So yeah, I hope that you find it useful, and then yeah, if there anything that you are still struggling with that you want me to cover, and or you have any questions or comment on the content that I've covered, please feel free to share with me on the comment section. And then yeah, and if you find this useful, please subscribe so that you don't miss out any future videos that I'm going to be sharing with you. And thank you very much for watching, and yeah, see you on the next video.